So in this video I'm just going to run through some of the questions for quiz 14, which is on SC26. Now SC26 is nanoparticles. We haven't actually done it in lessons, but that's because it's a very short, very straightforward topic, and all of the information you need is in your booklet from pages 67 to 70. Okay, so just 4 pages. And when you read through those pages, you'll see that there's very little kind of chemistry there. It's just a little bit of information about materials and their properties and their uses that you are just going to have to read through and learn. So the stuff that you actually have to learn by heart is on your carousel quiz, and then you just need to be able to apply that knowledge to these exam questions. You'll notice as well the exam questions are quite repetitive, and anything that you don't pick up instantly from the booklet you should be able to pick up from the mark schemes here. So this video is going to be short. Okay, I don't really feel there's much for me to go through, although if you do have questions before next week's or the quiz after half term, let me know. You'll see lots of these questions asking you to put things into meters. You need to know that a meter is 1 by 10 to the minus 9 nanometers. So if they give you something in nanometers, you're going to be multiplying it by 10 to the minus 9. So hopefully you can just do this in your head. Okay, if it's 100 nanometers, if I'm multiplying 1 by 100, then I'll need to times this by 100, and I'm going to get 10 to the minus 7. But if you struggle to do that in your head, you can do it on your calculator. Just do 100 by 10 to the minus 9 on your calculator, and it will give you the right answer, which will be 1 by 10 to the minus 7. The other questions that they typically tend to ask you are these ones here, where they ask you to calculate surface area to volume ratio. Always give you a cube. So to calculate the volume of a cube, it's going to be height by width by breadth, which is in a cube. These measurements are all going to be the same, 90 by 90 by 90. To work out the surface area of the cube, you need to get the area of one face, which is going to be 90 times 90. And you have got 6 faces, 6 identical faces, so I'm timesing that by 6. And when I work that out, I see surface area is 729,000, volume is 48,600. And then to simplify the ratio, just like I do an empirical formula, I just divide across by the smallest. So I divide both of them by 48,600, and I simplify that to 15:1, and that's my surface area to volume ratio. And you get 3 marks for doing that. So these are quite nice questions. Again, here 90 nanometers in meters, 90 by 10 to the minus 9. It's going to be 9.0 by 10 to the minus 8. You can do that on the calculator if you're unsure. This one 2.5 by 10 to the minus 8. They also love to ask you about size, putting things in order of size. The first sentence of your booklet will say, nanoparticles are bigger than atoms and molecules, but smaller than pretty much anything else. So here you've got a fluorine atom, you've got a chloride ion. Both of them are smaller than the nanoparticles. Your answer is going to be D. To work out between fluorine and chlorine, just look at their positions on the periodic table. That's in period 2, 2 shells. That's period 3, 3 shells. Don't be put off by the ion. You're not comparing atoms versus ions. You're comparing a period 2 element versus a period 3 element. Here again, smallest to largest, they give you a proton, right? Protons are found in atoms, so they're obviously smaller than atoms themselves. So it's going to be protons, then atoms, then molecules, because molecules are collections of atoms. You can have a small molecule, something like CO2, or you can have something much bigger, like a buckyball is C60, but they're still molecules. And then nanoparticles are bigger than molecules, so nanoparticles will go at the end. Another question about surface area to volume ratio. This time they tell you that each side is 2. So to get the volume, it'll be 2 by 2 by 2. To get the surface area, 2 by 2 by 6. And then you simplify that ratio. And again, you're getting 3 marks for doing that. They can ask you a few questions about catalysts and why they're effective if you use them as nanoparticles. If you think back to rates of reactions, we learned that if you've got an increased surface area, then you'll have an increased rate of reaction, and that will be what you'll be talking about here. Smaller particles, increased surface area, greater surface for the reaction to take place on, and then a faster rate of reaction. Another surface area to volume, again for 3 marks. Although that, did they ask you for it? Yeah, no, it's fine. It's the same as before. Blah, 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 blah. You'll find all this stuff about sun cream in your booklet. Again, nice and straightforward. This one, they show you how as diameter increases, so you can see you're going from 10, 20, 30, 40, 50, okay? sorry, just because this is the simplest ratio, this does not suggest that the surface area isn't increasing as the diameter increases. It does. The surface area will increase as the diameter of the spherical nanoparticle increases, but the volume will increase much quicker. So as the diameter increases, yes, surface area increases, but volume increases at a faster rate, and that overall means that you are decreasing your surface area to volume ratio. So when the two numbers are close together, so 3 and 5, we say we have a high surface area to volume ratio. When there's a bigger difference between the two numbers, we say we have a low surface area to volume ratio. So when they're asking you for the trend, you're going to say as the diameter of the nanoparticle gets bigger, the surface area to volume ratio decreases. I don't know why I wrote that totally wrong. Surface area to volume ratio decreases as the diameter gets bigger. So the further those two numbers are from each other, the smaller the surface area to volume ratio. And then they ask you to work out what it will be. So you just need to spot the pattern here. So if you look, I mean, surface area is 3 the whole way down, but you can see that the volume is always half the diameter. So 20 to 10, 30, 15, 40, 20, 50, 25. So if they're telling you that the diameter is 80, it's going to be 340, which is B. And then these, I think, are all straightforward. This one here, 17, again, in order of size. Sodium atom, so an atom is smaller. And then you've got an ethene and you've got starch. They're both molecules. Ethene, we should know, is this, so it's only got 4 atoms in total. Starch is a polymer, so a long chain, so a starch molecule is bigger than an ethene molecule, and then the nanoparticle is again bigger. It's going to be bigger than atoms, ions and molecules, so the nanoparticle will go at the end. Most of the other questions I think you should be able to get from the booklet or from the mark scheme, but if you do have any questions, ask me before your quiz, which will be the first Tuesday back after half term.